Okay, so the purpose of this screen recording is to demonstrate how to use the TI-Nspire in order to solve systems of equations. And so on the right hand side of the screen I have got the note that you were given a copy of in class today, and it details what steps you need to follow, and so I'll refer to those as I go. And so what we have here is I'm just going to work through the examples. As you can see, for the first example, our instruction is to solve the system of equations by graphing on the calculator, and a reminder, we must sketch what the calculator produces on the axes that have been provided, and we are then going to give the coordinates of the point of intersection, which is the solution. So we start off, the first step is to get each of these in y equals form, and that's so we can enter it on the calculator. So I'll come over to the calculator, and what we're going to do with the calculator is begin by creating a new document. And so we'll start off by going to the home page, which is shown on the screen on the right, and I'm going to create a new document, and what I want in this is a graph document. Okay, and straight away I'll see f1x, and that is going to allow me to enter the function. And so f1 in this case essentially represents y, so y equals, or f1x equals. And so in there I'm going to type x plus 1. So you see towards the bottom of your calculator you have the x, which is a variable, plus 1, and I'll just hit enter, and as we can see from the screen, we've now, the calculator has gone ahead and graphed that line for us. We're going to need to enter a second equation, and that equation is y equals minus x minus 3, and so we have two options for this. We can use the menu, and number 3 is a graph entry, but it is a little bit quicker and easier if we just use the tab button. So first of all, in order to get any menus off the screen, we just use the escape key, and that'll clear the menus for us. And then what I'll do is I'll just press the tab button, and as you can see, it opens a box at the bottom, f2x, so this will be our second function. So what I'm going to type in there is negative x subtract 3, and there I have my second function. As is clear, the two functions have a point of intersection, and the final piece for me is to find the coordinates of that point of intersection. I need to do that accurately, and so I'm not going to use an estimate. I mean, we could read off the graph and estimate that it's going to be approximately minus 2 minus 1, but we need to be a little more accurate, and so from the menu we'll have option 6, which is to analyze the graph, and we need to select intersection. Okay, and the last thing the calculator needs you to do is to give a lower bound, that is a point to the left of the point of intersection. Okay, and so I've moved my line to the left of that intersection, and I've hit enter. I open up to the right, and as you can see, it already puts the highlight on anywhere to the right of that, and I'll hit enter again, and here we have our point of intersection, or the coordinates of that point, minus 2 minus 1. And the last thing that you would need to do, if this were an assessment of course, is we do need to ensure that you have drawn or shown how you got this, and so what we're going to need is a representation or a sketch of those lines on the graph. So ordinarily I'd expect that you use a ruler for this, but in the interest of time I'm just going to give a very crude sketch. And so we have our one line over there with its y-intercept of 1. The second line I'll change colors. We are going for an intersection right about there, which gives me 1 point, and the second point I can obtain with the y-intercept of minus 3, and again I'm going to draw a rough sketch through those two, and that is sufficient in terms of showing work, with one added important step, and that is to mark down the actual coordinates of the point of intersection, which are the solution to the system. Okay, so I'll go ahead And I'll take you through that again with the second example. And so what we can see in this example is we have a little bit of preliminary work that we need to do. In each of these I'm going to need to rearrange the equation first. And so I've moved the x to the right hand side by adding, and I'm dividing through by 3. And of course there is a 1 in front of the x, so I get a coefficient or a slope of 1/3 minus, and we have 6 divided by 3, which is going to give us 2. So that's our first equation. The second equation over here I'll redraw in red on the right hand side. I'm moving the y to the right and the 7 to the left, and so I'm going to get y is equal to 2x minus 7. Those are the two that I'm going to graph. And so what I can do is, if I come back to the calculator, it's going to start to get pretty messy if I do those on the same graph. It'll be hard to figure out which lines I want the intersection between. And so what I'm going to do is come up here and add a page to this document. And so if you see in blue above the word document, we have plus page. So anytime you want to access the blue menu, we use control, and I'm going to click add page. And what I want to do is add a graphing page. You see, if you look up here at the tabs, 1.1 was the first example that I did. Those are the graphs that I did in the first one. 1.2 is now my clean graph. And again, it starts the numbering at F3. Don't worry about the F3. This just means it's a new function. So I'm going to go ahead and enter my 1 divided by 3x, 1/3 x, subtract 2, and that's going to be my first function of this system. And then the second function that I need, remember we can use the menu in order to get this, but the quicker way is to just push tab, and it opens up the function or equation entry box. And what I'm going to type in there is 2x subtract 7, hit enter, and now once again it's very clear. The two graphs have a point of intersection, in this case in the fourth quadrant, so we're expecting a positive x and a negative y. We could estimate, we're expecting an answer around about 3 minus 1, but as mentioned before, we're using the technology, we do expect a precise answer. So I'll go ahead and from the menu analyze the graph, and I want intersection. Once again, I need the lower bound, a point to the left of the intersection, the upper bound, which is a point to the right, and here we have, as expected, our point of intersection 3 minus 1. Okay, so very quickly I'll just draw a rough sketch of the two lines. And so we have got the first line, y equals 1/3 x minus 2, which looks roughly like that. Our second line was 2x minus 7, and so we're going to have our point of intersection about there. And again, I'm drawing freehand. I would expect you on an assessment to be using at least a ruler to be slightly more accurate and paying attention to the y-intercepts. Here I'm going to enter the coordinates, which is 3 minus 1. So of course the solution to the system, x equals 3, y equals minus 1. Okay, and then what I want to do is just spend a couple of minutes with the last example. It's going to be the same procedure, but it's going to throw up one small challenge for us, which I'll show you how to resolve on the calculator. So once again, let's come back to the calculator. A new system, so I want a new set of axes. So let me remind you, we want to add a page, so control, add page, and I'm adding a graphing page. As you can see, it goes to F5 because we've already graphed 4 functions in this document. And so I'll come back over here and just do some rearranging. And so the first equation, y minus 2x equals minus 6. And let me just erase because I'm blocking the second equation. So I'm going to rearrange that first equation. Y is equal to 2x minus 6. I'm going to rearrange the second equation, y to the right hand side, 19 to the left. And so y will equal 3x minus 19. Okay, over to the calculator. Let's enter those functions, and so we have 2x minus 6 is our first function, and then our second function 3, I beg your pardon, for our second function what we're going to need to do, of course, is push our tab button. Oopsie. So push our tab button, opens the function box, and what I'm going to enter is 3x minus 19. Now if you think about it, what we're going to do is hit enter over here. It's graphed both of the functions. There's no error, but as you can see from the graph, the issue that I have now is it's not clear where the point of intersection is. As you can see from the functions, we have a very small y-intercept at minus 19. Our graph only goes from minus 6.67 up to 6.67 and minus 10 to 10 on the x-axis. So what we need to do here is change the window, which is really the axes. And as you can see from the example as well, there are no numbers on these axes, and so this problem was designed to test whether we can modify the window to find what we're looking for. So if I come back to the calculator, what I want to do is go into menu, and you'll see window or zoom, and we have a couple of options. We can zoom out, or we can go to the window settings. I'd prefer we go to the window settings. That's going to allow you to enter a possible window. So this is the x minimum, so the x-axis goes from minus 10 to 10, and so we'll just make that, just to be safe, 20, so that we've got a little more space on the right-hand side. Then I'm going to tab down to the y minimum. So as we can see from the graph, it's intercepting, it appears in the top right-hand corner, so we don't need to modify the y minimum, but we will increase the y maximum, let's say to 25. And let's see how that modifies. And so essentially what we've done is made this box bigger by increasing x and increasing the y, and now we can see our point of intersection. And now the process is relatively straightforward as we did before. So menu, analyze graph, and what we want is our intersection, lower bound to the left, upper bound to the right, and our answer is 1320. And once again we'll translate that onto the graph here. This time I'll be even more casual in the diagram, but of course I would expect you to be a little more accurate and to label the axes. And so really the focus of that example was just to demonstrate how we can modify the window in order to find a point of intersection that doesn't fit on a regularly sized or typically sized graph. Okay, and that ends the display on how to use the TI to solve systems of equations by graphing.